Hi everyone. All right, so we are in our chapter 12. It's unit 9. It's on limits and derivatives. So in the packet, I am now on page 10. A lot of what I'm going to do today is a repeat of what we've been doing in the past two sections, 12.1 and 12.2. So we are talking about limits. And the limit as x approaches a of f of x equals L. The limit fails to exist when your function approaches a different value from the left side of a than it approaches from the right side of a. So we've been discussing that when we looked at the tables. Here I'm going to refer back. We've been talking about this when we did our tables. The limit from the left and from the right, the limit is approaching the same number 2, so it exists. From a graph, here's what it looks like. At 1, we're evaluating what's happening here in the graph at 1. From the left, the function value approaches 2. From the right, the function value approaches 2. So we're going to talk about that from the left and from the right, and there's special notation for that. So if we just look at from the right, it's called the right-hand limit. The limit as x approaches a. Now here's what's new, that little teeny tiny subscript of a positive. That means we are looking at the limit as x approaches a from the right. Alright, so you are thinking about coming in from the right. These are values of when x is going to be greater than a. Those numbers are to the right of a. If you think of a on a number line, all these to the right are greater than a. That's your greater than symbol. We're going to represent that as x goes to a with a little plus. Now if you're looking from the left-hand side, we're going to represent it as x approaches a with a little exponent of like a negative there. So that means we are approaching it from the left. So again, if a is your limit, if we're on a number line here, we're going to be saying, you know, what's happening as we're coming in from the left. And all of these values are when x is less than a. All right, so, and again, the limit, it doesn't really matter if it has a value exactly at the value of a. We are looking at how is the function behaving? What is happening as it's going towards a? So for an example, number 1, we have the limit of our function f, which is a piecewise function defined over 3 different domains. We want to know as x is approaching 2 from the right. That means, if we are looking at 2 from the right, that means x is, greater than 2. If we are looking at the limit from as x approaches 2 to the left, that is when x is less than 2, we are looking at this function. This one we don't really care about, because a limit looks at what is happening as you approach this value a from the left and the right. It's not really defined to be what it equals at that value. It's what it is approaching. It's what's the function's behavior. So let's first look at it from the left, because usually we read graphs from left to right. So I'm just going to start with the limit as x goes to 2 from the left. So this right here, this means x is less than 2. So the function that's defined there is x plus 6. So when we directly substitute 2 in, we get the function value 8. When we examine the limit as x approaches 2 from the right, that means x is greater than 2. That is defined to be a different function. It's 1/2 x squared. When you substitute in 2, 2 squared is 4. Half of 4 is 2. These are not equal. So the limit as x approaches 2 of that function does not exist because the limit from the left does not equal the limit from the right. So that's what we're going to be exploring right now. And if you were to graph these functions, this is a linear function. The y-intercept is 6 and the slope is 1. So at 2, it's not defined. We need an open circle But this is what it looks like for all the values less than 2. And then as x is greater than 2, it's 1/2 x squared. So again, it doesn't equal at 2, but if I substitute 2 in there, 2 squared is 4, half of 4 is 2, so that's the value 2, 2. But again, open circle because it doesn't say it's equal there. And the rest of this, it's quadratic. It kind of shoots up like that. It does not matter that exactly at 2, the function is defined to be 5. That doesn't matter. We want to know what's happening as it approaches 2. So the limit does not exist because it's 2 different values. So that's what it looks like graphically. We're seeing what's happening right here at 2. From the left, it approaches positive 8. From the right, it approaches positive 2. They do not equal, so the limit does not exist. All right, so again, the limit exists only if each of the corresponding one-sided limits exist and is equal to each other. All right, so they have to both exist, they have to be finite numbers, and they have to be the same number. For the limit to exist from the left, from the right, they have to be the same. All right, so let's look at another example here. So that last one did not exist. Let's look at this one. So we want the limit of this function. Again, it's a piecewise function as x approaches 1. So again, it's not defined at 1, but we don't care what's happening at 1. We want to see what's happening as the function approaches 1. What is the behavior of the function as it approaches 1? So we're going to look at 1 from the left. So from the left, that's less than, we're looking at the function x, or 4 minus x. Substitute in your limit value 1. 4 minus 3, or 4 minus 1 is 3. Let's look at it from the right. Now from the right, that means x is greater than 1. Our function is 4x minus x squared. Substitute 1 in, you get 3. These are equal. So the limit of f of x as x approaches 1, kind of combining both of these now, is the number 3 because the limit from the left equals the limit from the right. They're the same finite number. So we did an example of one that did not exist and one that did exist. So now it's time for you to try. All right? So maybe pause and try these on your own and then come back and check. I'm just going to continue. So we want to know what's happening as x approaches -1. So I'm going to be taking the limit as x approaches -1 from the left. That means it's less than -1. I want the function x squared plus 2. I'm just going to substitute -1 in there. -1 squared plus 2 is the value 3. Now I'm going to explore what is happening to the limit as I approach -1 from the right. That means your value of x is greater than -1. The function value where it's greater than is defined to be 2x. Substitute in -1, we got the number 2. So the result of all this, the limit as x approaches -1 does not exist. Well, I should stick the function in there. My bad. The answer is does not exist because these do not equal each other. All right, try it again. Same type of thing. We have a piecewise function. So we want to see what's happening to the limit as x approaches 1 from the left. It means x is less than 1. So x is less than 1 is this function right here, 3x minus 1. So if we substitute in our value of 1, 3 times 1 is 3, 3 minus 1 is 2. We are going to look at the limit as x approaches 1 from the right. That means x is greater than 1. That is the function x squared plus 1. So we are my bad, no 3 in that. So we are substituting 1 into this function. 1 squared plus 1 does give you the value 2. So the final result, the limit as x approaches 1 of this function f of x is 2. All right, let's check out a square root function. So we want to see the limit as x approaches -3 of square root of x plus 3. You can be graphical, numerical, or algebraic. All right, so I'm first going to try this algebraically. So I'm going to think about the limit as x approaches -3 from the left. Now, square roots, as you remember, hopefully, have a restricted domain. Square roots, we can't take the square root of a negative number. It's not a real number, that's imaginary. And limits, we want a finite real number. So as we're coming towards, if I substitute -3 in here right now, I will get a value. But if I'm coming from the left, I'm going to take a value that's smaller than -3. So let's pick -4. That's an easy one. If you put -4 in there, -4 plus 3 is the square root of -1. So this limit does not exist because the square root of -1 is not a finite real number. All right, let's look at the limit as x approaches -3 from the right. All right, so now you could substitute -3 in. So if you put -3 in there, you got square root of -3 plus 3. That's the square root of 0, which exists, so it's 0. These values do not equal, so the end result, the limit, as x approaches -3 of this function I'm running out of room, does not exist. If you were to look at this graphically, it has a restricted domain. So if you were thinking about what's happening at -3 as you're coming in from the left, I'm trying to put my finger on the function coming in from the left. There is none. It doesn't exist. If I'm coming in from the right, I can put my finger here. Coming in to the right, the function's going towards 0. But there is no function to the left of -3. So the answer to the whole problem doesn't exist. All right, let's check out 6. We want the limit as x goes to 0 of absolute value of 2x over 0. Again, if you substitute in 0, you get 0 over 0. So this might be better to look at the graph. So if you were to type this in, here's my x-axis, here's my y, the graph on the graphing calculator looks like this. Here's the value -1, the value +1. We want to see what's going on at 0. So we're kind of focusing our eyes here when x is 0. So if I want to take the limit as x approaches 0 from the left of 2x over x, again, this is where I take my finger and go to the left of 0, find the function, and follow it as I'm going towards 0. That gives me -1. The limit as x approaches 0 from the right, I'm taking my right finger, again, I want to see what's happening here. So my function's coming in from the right. It goes to +1. These are not equal. So the answer to the whole problem, the limit as x goes to 0 of this function does not exist. Okay? Then we have 3 more for you guys to try. You have to read very carefully. This wants the limit as x goes to 1. All right, so again, we need to look at what is the limit as x approaches 1 from the left. That means x is less than 1. The function when x is less than 1 is x squared. I'm going to substitute 1 in, so 1 squared gives me 1. I want to also look at the limit as x approaches 1 from the right. That means x is greater than 1. I'm using the function 3x minus 2. Substitute 1 in, I also get the answer 1. So the limit as x approaches 1 from both directions is 1. It's the same number. They equal each other. So it exists and it's 1. Okay, this next one. It just wants the limit as x approaches 0 from the right. That means x is greater than 0. It only wants this, the limit as x approaches 0 from the right. We are only looking at the square root of x. So if I substitute 0 in there, my answer is 0. It doesn't want the other side. I'm just reading carefully. If you look at this one, it only wants the limit as x approaches 1 from the right, which means x is greater than 1. This is only asking me to evaluate this function at 1. So substitute in 1, do your math, you get -1. All right, I'm almost out of time for this, but I'm going to do another video of page 13 and 14. Okay, bye.